Example 1. Find the remaining 5 trigonometric functions of theta. Give exact values. In part A, we are told the cosecant of theta is equal to negative 5 halves and that theta is in quadrant 3. All right, so let's do this. I'm going to work it with both methods. Something I want you to know going into this problem, you were told to give exact answers. This means that your answers cannot be decimals. Okay? All right. In all honesty, I prefer method 2. That's my personal preference. So I'm going to start and work it that way. And then I'll go back and show you how you can use the identities to come up with the same answers. Okay. I'm just a visual learner, as I'm sure many of you are. Okay. So here we go. We know theta. We know some information about theta. We know it's in quadrant 3. We know that the cosecant of theta is negative 5 halves. Okay. So what I'm going to do is draw an angle in quadrant 3. Okay. So I'm going to draw my x-axis. And then I'm going to come back and draw my y-axis. Okay, and you're not worried about having it be exactly perfect. Okay, you're just drawing a sketch here. Okay, so here's my y-axis. Trying to give myself room in quadrant 3. Okay, so here we go. All right, so I'm going to draw an angle. And think about when you draw an angle in standard form. Okay, the initial side of the angle needs to lie or coincide with the positive x-axis. And then for a positive angle, you rotate counterclockwise. For a negative angle, you rotate clockwise. So I don't know the value of the angle. We don't know what theta is. We just know it's in quadrant 3. So I'm going to draw the terminal side of the angle somewhere in quadrant 3. Okay, so it's going to look like this. Okay. So then, and I'm actually going to take the arrowhead off so it doesn't interfere here. What we're going to do is make a right triangle out of this. Okay. The way you make the right triangle in the correct way is you take where you left off here. This is the terminal point of our ray here. And we are going to draw straight back to the x-axis. Okay. You always draw back to the x-axis. Since we're in quadrant 3, the quickest way back to the x-axis is going to be drawing here. Okay, do not draw back to the y-axis. Okay, if you had instead drawn this way, that is incorrect. You have to draw back to the x-axis. Okay, this is going to be considered our reference angle. We can go ahead and call this theta. Okay, and this is the right angle. Okay, so this is how to correctly draw the triangle for this particular angle. Okay, now it's time to label sides here. Okay, we know the value of the cosecant, so we're going to use that to label sides here. Okay, remember in the third quadrant, x is negative, as is the y value. Okay, if you are dealing with the cosecant of theta being negative 5 halves, okay, cosecant, what is that? Okay, well, sine is the opposite over the hypotenuse. Okay, so if you flip that, you get the cosecant value. So the cosecant value is going to be the hypotenuse over the opposite side. Okay, so it's going to look like that. Okay, so you can kind of equate across the fractions. The only thing here, and I need to write this, the hypotenuse can never be negative. Okay, so if we are trying to equate negative 5 halves with the hypotenuse over the opposite, we know that the negative sign has to go with the 2. Okay, and the 5 needs to be positive. Okay, positive 5 divided by negative 2 is negative 5 halves. The hypotenuse is positive 5, and the opposite side is going to be negative 2. Okay, I know the opposite side is talking about the length of a side, and length can't be negative, but remember, we're putting ourselves in the plane. Okay, so when you draw this, okay, and you're using theta, angle theta, okay, you're going to go straight across to the opposite side. This is going to be the opposite side, okay? And then the hypotenuse is going to be the side directly across from the right angle. So this is the hypotenuse. That makes this the adjacent side. Okay, this is how you should be labeling your triangle. Okay, so the hypotenuse we said should be 5, positive 5. And the opposite side, we need to label it with negative 2. Okay, why is it negative? That makes sense because this is like a length of 2. It's 2 units below the x-axis. So this y distance would be negative 2. Like this would be negative 2 on the y-axis here. Okay, so that's how you start this off. Okay, we have 2 sides of the triangle. We need the third side. So we're just going to use the Pythagorean theorem. Okay, so we know for the Pythagorean theorem that c squared has to equal to a squared plus b squared. Okay, the hypotenuse is always c. Okay, a and b, it doesn't matter if you call a the opposite or the adjacent. Same thing with b, but c is always reserved for the hypotenuse. All right, so we're going to plug in here. This tells us that 5 squared is equal to, I'll leave a for adjacent, a squared plus b squared. B is the opposite side. Okay, and this is going to allow us to solve for the adjacent side. Okay, we're going to get 25 is equal to a squared plus, if you square negative 2, that's negative 2 times negative 2, that's positive 4. Okay, we're going to move the 4 over. We get that a squared is equal to 21. To solve for a, you've got to take the square root of both sides. Okay, so in doing so, don't forget, if you've got something squared equal to a number, you've got to throw a plus or minus out front. Okay, so a is going to be plus or minus the square root of 21. Okay, that's the possible values for a. We can't use both, so we have to make a decision. Do we use the positive version or do we use the negative version? Okay, well, look at what quadrant we're in. Okay, this is going to be the adjacent side, which is along the x-axis. The x-axis is negative. You have negative x values in quadrant 3. Okay, so you need to pick the negative version. This is going to be the negative square root of 21. Okay, so your triangle is properly labeled, and now we can just apply our right triangle formulas to get all 6 trigonometric functions. Okay, so I'm going to come down here. I have some blanks labeled. Okay, we can go ahead and fill in the cosecant. We know the cosecant is negative 5/2. That was given to us. So now we need to figure out everything else. Okay, so I'm going to come back up here and use my triangle. Okay, I will start with the sine value. Okay, so I'll come over here. I'll put it in green. So number 1, if we want the sine of theta, that is going to be the opposite over the hypotenuse. Okay, so just do it. The opposite side is going to be negative 2. The hypotenuse is going to be 5. Okay, you're done. Okay, so you can go ahead and label that. And it makes sense. Okay, because remember, sine and cosine, or sorry, sine and cosecant are just the opposites of each other. Flip the fractions. Okay, if you flip negative 5/2, you get negative 2/5. Okay, so that makes sense. All right, moving on. If we now want the cosine of theta, okay, if we want the cosine of theta, that is going to be the adjacent over the hypotenuse. Okay, so just read it off of the triangle. The adjacent side is negative square root of 21 over the hypotenuse, which is 5. Okay, that's it. This, don't get the decimal approximation. This is the exact answer. I don't want decimals. Okay, so if you come down here, the cosine is going to be negative square root of 21 over 5. Okay. All right, if we keep reading off of the triangle here, I'm going to move on and do cosine is associated with secant. Okay, the secant is basically the flip of the cosine. So this is going to be the hypotenuse over the adjacent side. Okay, so the hypotenuse, if you just plug this in, the hypotenuse is 5. Okay, the adjacent side is negative square root of 21. Okay, hopefully you know this from trig. You should always rationalize your denominators. Okay, meaning get rid of any kind of square root or radical in the bottom. Okay, to do this, I am going to take my quantity here and I'm going to multiply the top and bottom by the square root of 21. Okay, So this is going to give me 5 times the square root of 21 in the numerator, okay? The bottom, you'll have your negative sign. The square root of 21 times the square root of 21 is 21, okay? So the answer for the secant of theta is going to be 5 square root of 21 over negative 21, okay? And the negative can be out front, okay? So that is the secant value. I'll put negative 5 square root of 21 over 21. Make sure to rationalize those denominators, okay? Let's go look at the tangent. Okay, I'm going back to my triangle. Okay, I'll put the tangent over here. The tangent of theta is equal to the opposite over the adjacent. Okay, so if we plug this in, the opposite side is negative 2 and the adjacent side is negative 21. So this is going to be negative 2 over negative square root of 21. Okay, again, we need to rationalize the denominators here. Okay, notice that negative divided by negative is going to give you something positive. So the tangent value will be positive here. So I'm going to rationalize here. I'll go ahead and get rid of the negative signs. 2 over the square root of 21. We need to multiply top and bottom by the square root of 21. Now we can multiply across the top and across the bottom. This is going to be 2 square root of 21 over square root of 21 square root of 21 times square root of 21 is 21. Okay, so your tangent value here is going to be 2 square root of 21 over 21. Okay, last thing we need is cotangent. Okay, cotangent of theta is just the flip of the tangent. It's the adjacent over the opposite side. Okay, if you read this off the triangle, the adjacent side here is negative square root of 21. The opposite side is negative 2. Okay, negative divided by negative cancels. You're going to get the square root of 21 over 2. And there's no radical in the denominator to rationalize. So you are done. This is the square root of 21 over 2. Okay, we are done. Okay, we have found all 6 trigonometric functions with the given information. All of our denominators are rationalized and we have exact answers. Okay, in the next video, I will show you how to redo this problem, but instead relying only on the trigonometric identities and not using a triangle.